Binocular versus monocular vision. A new perspective. Even though we have two eyes, our visual system can use something called a monocular depth cue to infer three dimensions. A monocular depth cue relies only on one eye. Try closing one eye, and notice you will still see depth in the image below. Binocular vision is based on something called binocular disparity, which you will find to be a very important part of seeing in 3D, but first, let's get back to monocular depth cues. There are two different types of cues that allow us to experience depth. The first is a monocular depth cue. This is a cue that is available even if you only had one eye. Like, this guy, roar, roar. These cues include occlusion, where one of the objects is blocked by another object in front of it. Another cue is relative size. Notice how the smaller rabbits appear farther away than the larger ones. Another monocular depth cue is aerial perspective, which is a depth cue based on the implicit understanding that light is scattered by the atmosphere. More light is scattered when we look through more atmosphere. Thus, more distant objects are subject to more scatter and appear fainter, bluer, and less distinct. Linear perspective is another monocular depth cue. This is a depth cue based on the fact that lines that are parallel in the 3D world will appear to converge in a 2D image. All of these monocular depth cues are known as pictorial depth cues, which are cues to distance or depth. These types of cues are often used by artists to depict 3D depth in 2D pictures, such as amazing sidewalk drawings. So if there are so many monocular depth cues, why do we have two eyes? You might be thinking about evolution. We have two lungs, two kidneys, two arms, two legs, two ears, two of a lot of things, so why not two eyes? If we were to lose one of our eyes, we could still see. However, this binocular vision, having two eyes, gives us another important advantage. It allows us to see more of the world. Our visual field is limited to about 190 degrees from left to right. Using both eyes together gives us two overlapping images, helping us to experience depth. This is called binocular summation. But here's where it gets really interesting. Binocular disparity is a term that refers to the difference between the images falling on our two retinas. Stereopsis is the impression of three-dimensionality when you use both eyes. Each image is, of course, two-dimensional, but when combined this gives us the sense of depth. But it's a little more complicated than that. Most of what we see hits our eyes in different ways, meaning the light hits our retina differently on a different area in each eye. However, there is a certain area in our field of vision, called the horopter, where the light from an object hits each retina in the exact same place, as with the red dots illustrated below. However, the objects outside of the horopter will hit the retinas in non-corresponding locations as seen below with the purple dot. Notice the red dot which is within the horopter hits the retina in the same spot, which makes for zero disparity. The purple dot, however, hits the retinas in very different locations. Your brain then uses this information to determine the distance of the object. Specifically, it can tell whether or not it is in front of or behind the horopter. Study the image in captions below to get an idea of how this works. With cross disparity, your brain knows that the object is in front of the horopter, whereas if there is an uncrossed disparity your brain knows the object is behind the horopter. In the experiment we are about to do, you will be wearing a pair of glasses that eliminates binocular disparity while having both of your eyes open. They will show one image, from the same point of view, to both of your eyes via one camera. What do you think will happen when you put these glasses on? Will you be able to perceive depth using binocular disparity? If not, will you be able to use monocular cues? These are just some of the questions you should be asking yourself while wearing these glasses. Enjoy your activity. Roar. Roar.